All right, let's talk about the pH scale. In 1909, there was a Danish chemist. His name was S.P. Sorensen. He came up with the scale. It's called the Sorensen scale, but we most commonly know it as the pH scale. pH stands for potency or power of hydrogen scale. It's a log scale. That means for every pH value of 1 to 2 to 3, we're actually changing by a power of 10. So if you're going from pH of 1 to pH of 2, you would be decreasing the hydrogen ion concentration by 10. Okay? The equation is pH equals the negative log of the hydronium ion concentration. I will give this to you. Make sure you're using the negative key on the calculator and not the subtraction key, which will end up giving you an error. You may see the hydronium ion replaced with a hydrogen ion. It's the same thing, okay? Let's turn to the next page. There is technically a formal rule for determining sigfigs and logs. We're not using it. I left it in the book for you. I have never seen anybody teach it except for in Canada. Okay? Okay, let's go on to measuring pH. pH is usually determined with an acid-base indicator like phenolphthalein, which we use in a titration. But if you want to be really precise about it, you're going to use a pH meter, which we have used as well. Let's take a look at the next page. And let's take a look at this quick check really quick. So if you were asked to convert the hydronium ion concentration to pH, let's see, we're looking at orange juice. pH is the negative log of 3.2 times 10 to the negative fourth. So you're going to end up getting a pH of 3.49. I don't really care about sig figs here on the homework. I think I tell you how many places I want, like round it to blah, okay? If I don't, just ask me. For number 2, they say during a titration, the pH decreased quickly by 5 units from 8 to 3 at the equivalence point. Did the hydronium ion concentration increase or decrease, and by how much? Well, pH that's less than 7 is acidic. So that means the closer you're getting to 0, the more hydronium ions you have in the solution, right? So 8 to 3 means hydronium had to be increasing, okay? By how much? Well, if we changed by 5 pH units or numbers, that means technically it was 10 times 10 times 10 times 10 times 10 for every pH unit, right? Because it's a log scale. So that means 10 to the 5th is how much the hydronium ion concentration changed or increased, okay? All right, let's take a look at anti-logs. Have you guys learned logs in math class and anti-logs? Okay, so if we have the log of something, we can write that in a power of 10 form like this. So we would take the anti-log, which would be 10 to the negative pH. So this equation you use if you're given the pH and you're being asked to solve for the hydronium ion concentration, okay? Don't memorize it. I will give it to you, okay? Let's take a look at the practice problems on the next page. Ignore the number of significant figures column because we're not going to be doing that. So here, if you're calculating the pH and you're given the hydronium ion concentration, this pH is the negative log of 5 times 10 to the negative 5th, right? So this is going to be around 4.3. If you're going in the opposite direction, so over here, if you're calculating the hydronium ion concentration, this is 10 to the negative pH. So 10 to the negative 3.34. This is going to be 4.6 times 10 to the negative fourth. And since you're solving for a concentration, your unit would be molarity or capital M. Okay? Let's expand this P concept and let's go and talk about bases specifically. So up until this point, we were really looking at acidic solutions, or we were given the hydronium ion concentration or calculating the pH. pH can be added to something called the pOH, and that equals 14. So that would equal the pH scale, which runs from 0 to 14. So I can actually solve for the pOH if I have the hydroxide ion concentration. So I will give you this equation. Don't memorize it. And on the next page, they show you how the pH plus the pOH equals 14. Right here. I will also give you this. Some of these pH problems may be two-step problems. Okay, so you may be using more than one equation depending upon what you're given. And sometimes there's more than one way to figure the answer out. You'll end up getting the same thing in the end. These graphs are here to show you that the hydroxide and hydronium ion concentrations are inversely related. This looks just like the graph from Boyle's law, which showed that pressure and volume were inversely related. And then at the bottom of the page, we've got some more information on pH and pOH relationships for different types of solutions. So if you come down here, you can see that if pH equals pOH, we have a neutral solution. That means both values would be 7. If pH is less than the pOH, it's acidic. pH is greater than the pOH, it's basic. Okay? And then let's turn to the last part. I think it's the semi-last part here. There is a guide at the top of the page here in case you are sort of lost as to what equation you should use. I will not give this to you, but let's say you guys are solving for the hydroxide ion concentration of something and you're given pH, then you would flow this way using this equation to figure out the hydronium ion concentration, and then you would go this way to use this equation to figure out the hydroxide ion concentration, okay? At the bottom of this page, they give you this sort of keyboard-looking thing to show you that if you imagine this middle part that's bolded as a cursor, you can take it to the left or to the right to figure out simultaneously hydronium, pH, pOH, and hydroxide. Acidic is on the left, basic is on the right. Let's take a look at the practice problems. And then after the practice problems, is there anything in your book? Did I take out? I did. Did I take out what comes after that? Perfect. Okay. I want to do these practice problems because they're really helpful. So what I want you guys to do is I want you to do all of it. 1, 2, and 3. Let's see what you come up with. Okay. All right. Let's see. What'd you guys get here? 1 point something? They changed the temperature on us. Normally the temperature is 25 and the kW is 1 times 10 to the negative 14, but they gave us a temperature of 10 and they said, here's the kW at 10. Does that make sense? Okay, so what would you get for X? That? 5.05? Yeah. Okay. So that means this is the hydronium concentration. So pH equals the negative log of that value. What'd you get for pH? 7.3. Okay, so it's barely basic. Okay. All right, homework's open.